Good morning, friends. This is Durga from IT University, a one-stop shop to learn all the technologies. As you guys know, this is backup for the live training, and you can start learning going through these videos. These are being streamed to YouTube as backup for the people who are joining or who are learning as part of my paid classes. That being said, if you want to practice based upon the topics that are being covered, if you have an environment, that is fine. If you don't have, you can use labs.itversity.com. There are several plans: $14.95 for 31 days, $34.95 for 93 days, and $54.95 for 185 days. And also, whether you sign up for the lab or whether you are part of my live training or not, you can still ask questions on discuss.itversity.com, and we'll try to get back to you with answers. That being said, let me launch the WebEx session, and we'll take it from there. Good morning, friends. So let me get started. I'm changing myself as presenter, and I'm sharing my screen. As you, so this is almost like 30th or 31st session. And so far we have covered Scala as well as Spark in the first half of these sessions. And also we have covered Python a little bit. And then as part of the second half, we started with HDFS commands. Then we have covered Scoop in detail. Then we have covered Hive. So from now onwards, instead of breaking up into two different sessions, I'll be covering the same topic throughout the session. And still there are 8 to 9 more sessions. And in these 8 to 9 more sessions, in the next 4 or 5 sessions, we'll be covering streaming analytics using Flume, Kafka, as well as Spark streaming. And then we'll be covering all the other topics like Flume, Woozy, overview about Ambari, etc. And last 4 or 5 sessions, we'll be primarily focusing on performance tuning. We'll try to reconcile whatever we have learned, and then we'll be focusing on performance tuning purely. Whether it is MapReduce, Hive, Scoop, or Spark, for all those important topics, we'll try to identify a few performance tuning techniques, and we'll cover them in detail. So that being said, let me get started with today's topic. It's about streaming analytics, and when it comes to streaming, you need to understand multiple technologies like Flume, Kafka, Spark streaming is one of the popular combination. On in some of the projects they use Flume, Kafka, and Storm, and also Flume, Kafka, Flink is also quite popular in streaming analytics. Okay, so first let us understand what streaming analytics is. So streaming analytics means as the data is generated in real time, we should be able to capture that and then create micro batches for 2 minutes or 5 minutes or 10 minutes and run some analytics out of it, and then get insights by looking into the trends of those micro batches. There are a number of examples when it comes to streaming analytics you might see in real world. One of the things is, which I use quite frequently, is endorsements. Okay, so if you go to LinkedIn and if you go to profile, and if I search for someone else's profile, okay, I have second account called Big Data Mentor. It is not so active. Let me go to that profile, and let's say I want to endorse this guy on few technologies like big data, Hadoop, etc. Okay, so when I endorse, there are two things that are important. One is endorsee, which is endorser, which is me, and the technology on which I am endorsing. Okay, and if this data is stored in a raw table where you have all the details about endorser's email ID, endorser technology, etc. And whenever this big data mentor logs into his profile and go to this section, if at that time, if we have to run the report by aggregating how many endorsements are there for big data, how many endorsements are there for Hadoop, how many endorsements are there for PL/SQL, it will take some time. So rather than aggregating at the time of request, means whenever this big data mentor logs into his profile and try to see the endorsements he got, if report generated at the time, then obviously the performance will be slow. It has to group the data, it has to sort, it has to aggregate, it has to do quite a few things. And with the platforms like LinkedIn, where there are millions of users, if there are at least at any point in time, there will be hundreds to thousands of users who will be checking their profiles, or the profiles might be checked by others. At least few hundreds or thousands will be consistently viewed by recruiters or by hiring managers or whoever it is. And if these aggregations have to happen at the runtime, then your database will become overhead, and aggregations and reporting will become overhead. For that reason, it will be better if we can stream as and when people endorse, if we can stream those details and process every minute or 2 minutes and update a new table which will store the aggregated data, which will group the data by the endorsed technology, and also give the count of endorsements of it, and also most recently endorsers. Then the amount of work which needs to be done is much lesser. To make this happen, probably the application should be smart enough. So whenever I endorse someone or someone endorses some other person, these things has to be logged somewhere. It should not be the database. If it is database, then the performance will be poor. It could be some other system, typically web server logs, and we should be able to pull those web server logs and identify this information, and then use this to do some aggregations every minute, every 2 minutes, or every 5 minutes, whatever is the SLA, and store the information into the aggregated table. And if we can achieve that, then your data is pre-aggregated, and the reports will be rendered as fast as possible. So this is one of the classic examples for streaming analytics, the endorsements in LinkedIn. So if you have any questions, let me know, because it is very important to get the context where the streaming analytics is relevant, and then we will get into the technologies which can be used for different purposes as part of the streaming analytics. Another example is if you go to Facebook and if you check for some person's profile, for example, Obama or Donald Trump, okay, and if you, let's check president's profile, and if you click on likes here, you will see this report which will be refreshed quite frequently, right? Probably I think it will be reported once, or it will be refreshed once in 5 minutes, or once in 10 minutes, once in an hour, or it could be once in a day. So these aggregations should be pre-computed so that the results can be retrieved as fast as possible. And again, the way it will be done is whenever people like his page, and the information has to be logged into some application logs or web logs, and from there we should be able to capture the information, and we should be able to update the aggregated table, the table which will contain the aggregated data. This is another classic example for streaming analytics. Okay, so that is basics about streaming analytics. Now let us understand different technologies. Okay, for that purpose, I will try to run an example, okay, where multiple technologies such as Flume, Kafka, and Spark streaming is used, and I will demonstrate first, and then we'll get into each of these topics quickly. Okay, so for this purpose, if you log into the lab as your lab user, in my case it is D Gadi Raju. Okay, so now I logged in as a lab user, not an admin. So when now if I run tail underscore logs.sh, okay, yes,
This is Ravindra.
yes,
Is there anything you are sharing? I don't see anything yet.
I am sharing my screen. Rest of the folks are able to.
Because I just see a green color page. That's it.
Can you log off and log in? What about others? Can you guys see my screen? Yeah, Ravindra, it's only with you.
Okay. I'll relog.
Yeah, I will continue because you are aware of these things. Okay. So here there is an application called taillogs.sh, and if you see when I run that, okay, thank you. So YouTube is not seen. I don't. It is fine because I can see the Hangout here. Okay, thank you. So YouTube is not seen. So let me start again. Thank you very much for someone who pinged me that they cannot see, but it's saying sharing. So probably I might not have shared entire stuff. No, it seems to be fine. So let me start again. I stopped now and I'm starting the sharing again. So let me check now. I stopped now and I'm starting the sharing again. Yeah, now it is fine. So let me check now. Okay, I hope you guys can see the screen now on YouTube. I don't know, sometimes it behaves weird. Everything, and thank you for someone who reminded me. And sometimes even though it does not show, after streaming is completed, the video will be fine. I don't know, probably some technical glitches with respect to YouTube, probably some bugs. Anyway, now if you go back, what I'm saying is, if you log into the lab with your lab ID like this, and there are a few scripts that are available on the lab. If you go to cd/opt/gen underscore logs and run ls-ltr here, you see start underscore logs, stop underscore logs, and tail underscore logs.sh. So these three can be run from anywhere. They are added to path, hence you will be able to run from anywhere. So start underscore logs.sh is primarily to start generating the logs. So first, the way you should start is by running tail underscore logs.sh. And when you run tail underscore logs.sh, it should actually refresh your screen by adding more and more entries. So it actually simulates as if your web server logs are being generated. This is just a simulator. I got this from Cloudera. Cloudera is the one who developed that package, and I'm using that for the demonstration purposes. Okay, so start on the tail underscore logs will confirm whether the logs are being generated or not. If you want to stop, you can stop logs.sh and it will stop generating the logs. Once you stop, if you run tail logs.sh, now you see it is not refreshed. It is not being refreshed because we stopped the logs. If it is not being refreshed when you run tail underscore logs.sh, just run start logs.sh and it will start generating the logs. You can confirm it by saying tail underscore logs.sh. Okay. Now you can see that logs are being generated. And let us define the problem statement. The problem statement is, I want to see every 3 minutes how each of my department is working. Now, how is the business of each of my department? That is the use case. Okay, and if you try to interpret the data here, it give IP address here. These are all fictitious IP addresses and timestamp, and then the REST API call, which is get in this case. So when someone try to do something on a particular item within the website, it will do get REST API call of get. And here, if they are looking to buy a product within a category, it will actually give the so this is actually confirm that we are trying to get something with respect to one of the department, and then the several departments are there within the data set. So these are high level departments, apparel and fan shop, many other things, and then you have categories, and then you have products. Here the analysis is how people are accessing the products in each of the department. Okay, so if I can extract this information and get this one and try to get the count as the data is streamed every minute, for every minute we can see how each of the department is performing every minute. Okay, so first we need to capture data from these logs, which is being updated by your application in real time. So to capture the logs, one of the most prominent technology within big data ecosystem is Flume. So we use Flume, and when you use Flume, you can so we will get to see the architecture of Flume, but at a higher level, there is something called source, there is something called channel, and there is something called sink. Okay, source is the component which will read the data. So we have to configure Flume source to read data from here, and channel is to channelize the data. I will cover later. Sink is the target to which data needs to be written. Okay, it can be HDFS, it can be relational database, it can be anything. In our case, instead of directly loading into HDFS and then running analytics on top of it, we want to use something called Spark streaming. And Spark streaming will actually read the data which is written by Flume, and we can actually start doing the analytics. So the integration point between Flume and Spark streaming can be multiple technologies. It could be out of the box Flume based technologies, or it could be Kafka. So in this case, just to demonstrate how Flume, Kafka, and Spark streaming works, I will quickly give a demo, and then I will break into pieces and get into few important details with respect to Flume, few details with respect to Kafka, and few details with respect to Spark streaming over the next 2 hours or 1.5 hours, and also as well as tomorrow and day after tomorrow sessions. Okay, so here under my account D Gadiraju, I have a directory called K&F. I just named it saying integration between Kafka and Flume. Okay, and here I have multiple configuration files. So first thing you need to remember is, if you want to run Flume, I will cover the architecture and all those things later. You need to start something called agent, and that agent requires configuration file. So in this case, we will be using fksync.conf, which is Flume and Kafka together .conf. Okay, and if I log into, or if I open that file, don't worry if you do not follow completely. I will cover in detail about how to create this configuration file and all those things later. For now, I will be focusing on the demonstration so that you understand what we are trying to learn over a period of next couple of days, or today as well as next couple of days. So vi fksync.conf. So as I have mentioned, whenever you hear something called Flume, the main thing that needs to come to your mind is source, channel, and sink. Source is primarily to read the data. channel is to channelize the data, and sync is to write data to something like Kafka or HDFS or some other technology, wherever you want to write. It all depends upon how you want to process the data and drives what should be the sync for your flow. Okay, so here if you see, when it comes to, so fk sync will be the agent name. So if you see each of the line, it starts with fk sync. So when we actually start the Flume agent, we have to give this name. Okay, and then source name is source one. You can give as many sources as you want within the agent. In this case, we'll be only reading a file in this location. Okay, so exec is one type of source. So exec is one type of source. We'll get into details about what exec and what other sources we have. Primarily, exec is used to tail logs or to issue some Linux-based command or Unix-based command and get data out of it. Okay, so in this case, if you are familiar with the tail command will, especially with -F, it will keep on refreshing, or it will keep on streaming the data into the tail command, and you can read the data. So for example, if I copy this one, I am logging using another session. Okay. Now if I run that command tail-f, and if you remember, my genlogs application is under this location. So whenever I run start_logs.sh, it will keep on updating this access.log file. Okay, now if I run tail-f, you see data is being read to standard out in streaming fashion. Whenever data is logged into that file, we are trying to read it immediately. Okay, so this exec source will actually start reading data from that log file in real time. And then we have to channelize the data. There are different types of channels. It could be memory, it could be file, it could be Kafka channel. In this case, I'm using memory, and again, I will cover this thing later. And then sync will determine to which data has to be written. Okay, here the sync name is sync1, and the type of sync is Kafka sync, and topic is fk sync. This is the topic name. So Kafka have something called topic, and we have to give name to it. And then broker list, we need to make sure that these are valid brokers. And if I go to Ambari, okay, so don't try to start your own brokers in the lab. It will cause some issues. Rather, try using the existing broker. Okay, already Kafka have the broker. It is started only on one node. So here I am giving nm02.itversity.com. Okay, so and then port number is 6667 in our case. Okay, to get the port number, you have to go to the configurations of Kafka. And here you see, this is the port number which we have to give over there. So listeners will determine the actual port number. Okay. So this is the sync type, which is Kafka sync. And out of the box, there might be some syncs, there might not be. If there are no syncs out of the box, we have to integrate. I will again explain those things later. Okay, anyway, to interpret all these things, you need to understand a few of the important Kafka concepts, and we will see that whenever we talk about Kafka, probably tomorrow or day after tomorrow. Okay, for now, just remember that we are trying to sync the data to Kafka, and Kafka is nothing but a queue, and this will actually be writing data to a queue, and then or publishing data to queue, and then we have to use Spark streaming to capture the data from the queue. Okay, so let me come out of this, and the main thing which you need to understand at this time is this first section. of each of the line, it has to be the agent name. So whenever we try to start this start agent with this configuration file, we have to give whatever is there as part of the uh, first portion of this parameter names. And then sources will give sources, channels will give channel details, and sinks will give sinks details. And source and sink has to be connected through channel. So if you see fsync sources.source1.channels is given as channel 1, and also fksync.sinks.sync1.channel is given channel 1. So these two, the source and sink, are primarily connected through channel. Again, I will cover those things later, and you will understand. Okay, so for now I am running a command called flume-ng. This is the command which will start the agent, and then you have to give the subcommand agent, and you can give the name. Either you can give -- name or just -n, and your name should match this portion of your configuration file. Okay, so fksync is the agent name, and then -c or --conf. You can use one of them to give the configuration directory. So in this case, I am giving the current directory, which is /home/dgadiraju, and then k and f. Okay, and then we can give either --file or -f. Okay, and then we have to give the configuration file name. This is very important that you give correct path for the configuration directory and the file name. Okay, and then hit enter. Okay, now you should go back and see that there are no errors. Your sync should be started. So sync is added here. It should be started. It should be created and started. Similarly, the case with channel and also the case with source. Everything should be started without any issues. Okay, and before using any downstream technology, now the data is being pushed to Kafka. Kafka is nothing but queue, and queue will not make any sense unless you start consuming from that queue. So either you have to use some streaming technology to read from queue. It could be Star, it could be Flink, it could be Spark streaming, and we'll be using Spark streaming to do that. So before we start using Spark streaming, it is very important to validate that whatever data being generated in the log file is being streamed to the Kafka queue or topic. It is called as topic in the Kafka terminology. You need to make sure that the topic is receiving the data. But you have access only to gateway node. You will not be able to go to the node where Kafka broker is running to validate. But if something is not working, you can raise the issue saying that, hey Durga, I'm not able to read the data from Kafka. Please get into the Kafka broker or topic and see whether it is receiving the data or not. Then I will troubleshoot the issue and I will get back to you. So it will be the responsibility of the administrators. Or in some cases, developers will get temporary access to that node where the Kafka is running, and he himself will be able to troubleshoot the issue. Anyway, now I am coming out of my account and getting into root, and then I am logging into NN02 where the Kafka broker is running. Let me check. Let me confirm where my Kafka broker is running. It's NN02. NN01, it is stopped for some reason. And then under HDP 01, so again, this location is determined by at the time of setting up the cluster. Okay, if you go to configs here, so this is the location where you will get the topics created or queues created. Okay, so I'm going to HDP 01 Kafka logs, Ideally, I should have deleted this one. It should not be there, but that's fine. And here, okay, I did not get it here. So let me go to another one, HDP 02 Kafka logs, and you can see the queue is. So what is this FK sync? If you go back to the configuration file, okay, now the agent is running. So let me open one more session. Okay, K and S, ls-ltr, cat fksync.conf. If you open this file, you see the topic name. Topic name is also fksync. So with that fksync, there is a directory here. Fksync is the prefix and -0 because Kafka is a distributed queue. Because it is distributed, it will have index of each partition within the queue. Okay, that's why you have -0. Now, if I go to fksync -0 and then ls-ltr, you see the log file here. So let us do date. It's current date, and that means it is getting the data. You can also run tail -s on this log file to confirm that we are getting the data. Okay, so now we are getting the data. We have confirmed that Kafka is getting the data. As it is getting the data, now we should be able to read from this queue, and we should be able to consume data from this queue and do whatever we want. Okay, and for that, I have written a Spark program, which I will just show now, and we'll get back to that later about how to actually write these programs. Okay, so here if you see, I want to rename it as department wise count. Okay, and then if you see here, I'm running in local mode. We can run in cluster mode also if we want. Okay, and here there can be multiple topics. So when you actually try to write the data or read the data, you can read data with one Spark program from multiple topics. So here I'm actually reading only from one topic, but the reason why I'm converting into set is there is a program called create direct stream under Kafka utils, which will take all the topic names as set. Okay, for that reason, I am just converting this in single string to set. Okay, we can also, I think we can also write like this. Set fksync. This is also good. But the reason why I have written like this is in case if we have multiple topics and if we actually pass it as argument, we have to apply split on that argument, which will get the topics details, and then we have to convert into an array, and then we have to convert into set. Okay, because using the delimiter, we have to convert in all the topics into an array using split function, and then we have to convert into set so that we eliminate all the duplicates. And it requires set as fourth parameter as part of this create direct stream function. And then Kafka parameters. So Kafka parameters, we have to give the blocker list. At this time, it is only running on NN02. Hence, I'm deleting the other one. Yes, you can set your topic name of your choice. Topic is nothing but queue. So your queue name could be anything. Let me take this call, okay? Hello. So I am back. So here we have to give the Revati. I will talk about all those things later. I will break down into individual components, and I get into each of those things later. Okay. So here we just need to pass uh, whatever IP address and port numbers for each of our broker, and we have to create a map out of it, and this map has to be passed as parameter. Okay. And then SSC is nothing but streaming context of Spark, using which we can read the data in real time. Okay. So these messages will be now reading the data in real time every 60 seconds. It will queue up for every 60 seconds. And on that data set of 60 seconds, we can do whatever we want. Okay. So here, I am extracting. So actually, the message will have both header as well as body of each message. And I'm interested only in the body. I don't want to process the header. So first I'm applying the map function to get the header. So the data type of messages is dstream. So we need to understand all these building blocks of Spark streaming, which I will be covering either tomorrow or day after tomorrow. So messages is similar to RDD, but it is called as dstream, discrete streaming messages. And it has several functions such as map, reduce by key, etc. Okay. And then if you go back to the data set, which we are trying to process, I want to read each message, which is this one. Okay. And only get data related to department. I don't want to get into products and other details. So I just want to understand the performance of each of the departments. So I'm just filtering for get department as part of this filter call. Once the data is filtered, this lines filtered is another dstream, which will have filtered data with all get department in it. And then I am writing the aggregate function, which is reduce by key and window. So for now, I will just use reduce by key. I will explain key and window later. Okay. Okay. And then I'm just printing. I'm not writing it anywhere, but you can have whatever logic you want. You can either write into HDFS using save as text file. You can connect to a database and write into database. So it's up to you how you want to do it. And then ssc.start will actually start the streaming process, and it will wait until you terminate it. The termination can be issuing kill command to kill the process that is running, or if you just launch using Spark submit command in the foreground, you just have to hit Control C or something to kill the session. Okay. Now what you have to do, you have to build the jar file out of it. So let me go to this location. Okay, and then SBT package. It will create the jar file. Okay, and one more thing which you need to focus is the build.sbt. If you go to build.sbt, you have these additional packages such as Spark Streaming 2.1, Spark Streaming Flume, Spark Streaming Kafka, etc. And you don't find these additional packages on all the nodes in the cluster. So whenever you submit the Spark job, there will be some some dependencies which will be available on all the nodes in the cluster, and there will be some dependencies which are explicit to the job. And those dependencies have to be passed as part of your Spark submit command, especially this Flume, Kafka, etc., and also few dependent jar files. All those things have to be passed to submit this jar as a job. Okay. Again, we'll come back to this later. I will explain slowly one after the other when I go into each individual component one at a time. So first we need to copy this file, scp, this jar file, and then dgadiraju at bw01.itversity.com. I want to copy to home directory, and I need to get my username. So I'm going to labs.itversity.com. Copy password. Paste it. Okay, now I am logging into the lab. Again, before we run this job, we need to make sure that our agent is up and running. Here you can see that agent is up and running. And we need to make sure that data is being streamed to Kafka topic or queue. So I have explained in the beginning, Himanshu, the log is generated because of an application called genlogs, which is available under /opt. There is start underscore logs, there is stop underscore logs, okay, and also there is tail underscore logs. So I ran start underscore logs, and then I started this Flume agent, which is reading data from that queue, and then publishing it to Kafka topic or Kafka queue. Okay, so Flume agent is the one reading data from the weblog, the log file, and publishing it to Kafka topic or Kafka queue, which is the name is FK sync. So now I am validating whether the data is being generated or not, again before we start the program. Okay, so here if I run taillogs.sh, we can see data is being generated on the source, and our agent is running. Okay, so agent is started by me, and I leave it like this. I didn't submit it in the background. It is running, and then I am in the NN02 where the topic, where my topic related data is being published to, or where my queue is being built. Okay, and you can do ls-ltl, and you can see the timestamp which is current. You can also set tail-yes log. So we are getting data to our Kafka topic. Okay, now we want to start the Spark job. We have to use Spark submit only. Okay, and we have to give the class name. So class name is Kafka count, and then we have to give jar files, because we have all the dependent jars. You can give it in double quote with comma separated. I will get those things, and then you have to give the jar file name, which is wc underscore. Okay, it's not in this location. It's in my home directory. Okay, and then wc. This is how you should run. If you run this, it will not work. I already have a command in my history, so I'm getting that one for now. So this is the one. So in this case, Spark submit hyphen class Kafka count. I should have used means if I want to use yarn, I have to change it to yarn client here. So probably here I have to say local. Ideal way is to externalize and pass dev or prod as parameter to the jar file. And here you can see I am adding Spark streaming jar file. Spark streaming Kafka jar file because I have to give data from Kafka queue. And then there are some additional dependencies which you need to figure out as you run. One is Kafka itself. So this is the actual Kafka related jar file. This is Spark streaming Kafka. Okay, and then finally there is something called Yammer metrics which is required, which have internal dependency from Kafka to it. We have to pass all these things. There might be better way as well to deal with jar files, but one of the crude way of doing it is to pass all the jar files like this. Okay, and then you can run the program. So we have given 1 minute. So streaming will happen every minute. And for that minute, whatever data it gets from Kafka will be queued. And then it will run the streaming analytics where we will get the details about how each of our department is performing. So we'll wait. Okay, there seems to be some issue. Array index out of bounds exception. Okay, so let us see if there are any issues reported from our program. Most likely it is because I am running locally, but we'll see. Yeah, Kafka count, anonymous function apply. Okay, so let me change it to yarn mode. Okay, so now I have to build the jar file. I'm exiting here, SBT package. Copy password, SCP. Okay, now let me run this Spark submit command. And now it should be run as yarn. And also let me check the broker list. Broker list looks good. We have to wait for a minute. If it failed this time also, then I will troubleshoot later. we will go ahead and start exploring the topics individually. First, we'll start with Flume. Yeah, now you see. So the department golf is tested twice, fitness once, and apparel once in the last 1 minute. What you can do, you can actually store this data into a database and with the timestamp as key, and then you will be able to generate reports out of it using any visualization tool. Okay, so that is the purpose of what we are doing. I have taken the simplistic example to show end-to-end flow, but the main purpose is to store this information rather than printing, to store this information in a database such as NoSQL database or traditional RDBMS, and connect your visualization tool and generate reports out of it in time-bound manner. Okay, so any questions here from end-to-end flow perspective? If there are any questions, I will take. Otherwise, we will get into Flume. I will give a minute or two. You can think about it and you can ask any questions. For some reason, it is failing. I don't know why it is failing. Again, it has given array index out of bounds exception. Probably it might not be getting the data. Probably people might be just killing and I don't know why, but yeah, earlier it used to get the data without any issues, but now it is not getting the data, which is causing that index array out of bounds exception. But at least we are able to get data for 1 minute. Okay. Any questions here? So before getting into Flume, one of the very important thing which you need to keep in mind is using correct IP addresses and port numbers. Never ever test any of these components with localhost. Okay, if you try with localhost, it will work without any issues. But when you get into the cluster, it will run into all kinds of issues. Instead of using localhost, try to simulate leveraging multiple nodes in the cluster and try to use some of the important tools to troubleshoot the issues before before you raise those things. First, you need to make sure that everything is running as expected. Okay, that's why I have shown end-to-end to begin with. IP address and port number is very, very important. In this case, our Kafka broker is running on port number is running on nm02.itversity.com and port number 6667. Okay, it should written like this instead of saying not reachable or something. Okay, this telnet or nc command can be used. Same thing, you can also say nc nm02.itversity.com and then 6667. It will confirm that you are able to communicate with the hosts without any issues. Okay. With NC, it will hang like this. Now, let us break into pieces and try to understand what is the relevance of Flume and then Kafka and then Spark streaming. So, as we have seen, if you want to read data in streaming fashion from any source, Flume is the to-go tool with respect to big data ecosystem. There might be alternatives, but Flume is the to-go tool with respect to big data ecosystem as of today. So you have to use Flume, and let us start with the architecture of Flume, and let us try several examples of Flume. Okay, so if you go to Google and search for Flume user guide, always you have to use user guides. Don't go for developer guide. Even though you are an application developer, from Flume perspective, you are an user. You are not developing something for Flume. You are trying to use Flume. For that reason, you have to use user guide, not developer's guide. Search for Flume user guide, and 1.7.0 latest version is fine. We have, I think, 1.5 or 1.6 on our lab. Okay, but most of the things does not change. And if you look at the architecture of Flume, so Flume itself, so when if you go to Ambari and if you click on Flume, okay, go to summary, it says Flume installed on 7 hosts. It does not have any daemon process which will be running all the time. It is just a client-only tool. So Flume is available on all the hosts, and if you have access to all the nodes, you can start Flume agent on any of the node. As you guys have only access to gw01.itverse.com, you will be able to use only that one to start the Flume agent. Okay. So now, if you look into the Flume's architecture, or Flume agent's architecture, Flume itself is a client-only tool, but when you start agent, it has 3 main components, which is source, channel, and sync. Okay, and if you look at the picture, if you want to read logs from the web server, you have to do it through source. If you want to write into some HDFS or relational database, you have to do it through sync. And to communicate these things, you can use channel. Okay, and this is standalone setup of a Flume agent, and this Flume agent should have access to your weblogs and also your Hadoop cluster. Only then it will work. Wherever the Flume agent is started, it should be able to access both the source as well as sync. Okay, sometimes you might have weblogs remotely and on a different server. So in this case, this genlogs is running on gw01.itverse.com, and also our Hadoop cluster is accessible from gw01.itverse.com. So we can run one agent on this, which will be reading from the log file and writing into HDFS. But in some cases, your weblogs might be generated on a separate host completely, which is out of the cluster. So there are multiple ways to deal that problem. Either you have to get the logs in timely manner, or you have to mirror the logs in timely manner to the host where the agent is running, or you can also start your agent where the weblogs are being generated. Okay, so this one you can have this agent on a server where your weblogs are generated, and then at your sync layer, you can pass data to another Flume agent over a network. So it requires IP address and port number, using which it can actually push the data, and then another agent can actually read the data from this using Avro RPC, and it will be able to channel and sync it into some other target. So this is multi-agent flow. So where your weblogs might be generated on a separate host, and your Hadoop cluster or whatever target is on a different host. And to communicate between these two, you can have 2 Flume agents running, and the sync of one Flume agent will be integrated with source of another agent using Avro RPC. RPC stands for Remote Procedure Call. Okay, and there are different architectures, which is consolidation. In some cases, you might have multiple web servers, and you might want to consolidate into one target. In that case, you can have your Flume agent running on each of these hosts where your web servers are being generated, and then you can have one target, one agent running on target, which can accept data from all the Avro syncs, and then you can consolidate and push it into whatever target you want to. So these are different types of setups which we typically do with Flume. One more is multiplexing the flow. So you can actually get data from one source and then channel through multiple syncs to different channels. And one sync might write to HDFS, and the sync might write to JMS, and another sync might write to some other Flume agent. So you can have several permutations and combinations of setting up these Flume agents. Okay, so this is the architecture of Flume. Any questions here before we get into more hands-on examples? Okay, it seems there are no questions. Now let us write the first simple uh, uh, Flume uh, Flume configuration file and then start the agent. So this is kind of hello world or getting started example. So you can copy this one and go to the gateway node and create a Flume example directory. So let me create a directory first. mkdir Flume example. Okay, and then you can say va example.conf. You can give any name to the configuration file and paste this one. Okay, so as we have seen in the architecture, what it have, source, sink and channel. So this example also try to start with that. So you have a source, you have a sink and you have a channel. So the agent name, so if you look into the configuration file, these are nothing but key value pairs or name and value pairs. So this is the name of the parameter and this is the value of the parameter. Okay, and the name of the parameter uses dot as delimiter, and your first string determines the name of the agent. And if you see, all the lines have same string, which means when you start Flume agent with this configuration file, you have to start with this name. This is the integration point between your Flume ng agent command and the configuration file. Your configuration file name can be anything. In this case, it's example.conf. Okay, and then as I have mentioned, at bare minimum, a Flume agent will have source, sink, and channel. So here I am giving the name to the source, a name to the sink, and a name to the channel. Okay, so the source name is R1 for this agent A1, the sink name is K1, and the channel name is C1. Okay, now let us determine what type of source we should use. This in this example, the type of, so for any source or channel or sink, the mandatory parameter is type, and the type is determined by the types which are supported by Flume out of the box or which can be integrated using third party tools. Okay, so now if you see here Flume sources, there is a Avro source. So if you want to read data from Avro, you can use Avro. There is thrift source, there is exec, which is to run a command such as tail-f on the log file and get the data in streaming fashion from the source. So what this Flume source will do is it will keep on polling the output of the tail-f command, and it will pass that information through channel to the sink. Okay, there is a JMS source, there is pooling source, there is a Twitter 1% Firehouse source, which is experimental. There is a Kafka source, so you can actually read data from Kafka broker. There is a Netcat source. So Netcat is primarily for the exploratory purpose, just to understand how the Flume works. Okay, and if you want to use Netcat, in this case we are trying to use Netcat, and you can see that 3 parameters are in bold, and those are type, bind, and port. So type will actually tell what type of source we are using. In this case, we are trying to use Netcat as source. Bind is the IP address on which this Netcat has to run. Netcat is nothing but a web service. So when we actually start the service of this agent, because we are using source type as Netcat, it will start a web server which we can connect to, and we can interfere by using MC command, and we can start sending messages to the Netcat web service, and then that data which is typed will be streamed through channel and through sink, and then we'll get the data. Okay, so this actually tells that, okay, my source is of type Netcat, which means a web service has to be up and running. So Flume agent will start this Netcat web service, and this is the IP address, and this is the port number on which the Netcat web service will be started. Okay, and then sync type is logger. Logger means write into Flume agent logs. Okay, it is also an exploratory type. If you want to get the other sync types, you can go to the index in the documentation. After sources, you will see the syncs. Okay, after sources, so these are several sources which is supported. Okay, after sources we have sync. One of the sync is HDFS, which will be covering later, but for exploratory purposes, we can actually use logger. Okay, and then channel. There are other services, other things also. So we'll see Kafka. We have used Kafka earlier, and now we are using logger, and we will see HDFS also. So depending upon your requirement, you have to explore relevant sync. Sometimes you might have to get the third-party sync also. Okay. Then after sources and syncs, we have the channel. Channels are memory channel, JDBC channel, Kafka channel, file channel. Typically, we use memory channel or file channel or Kafka channel. Okay. Memory channel will actually once the data is read from source, the data will be buffered into memory until the data is read by the sync. So there are two important parameters with respect to channel. Again, if you click on the channel here, which is okay here. After sync, we have channel, memory channel. If you go to memory channel, you have type which is mandatory, and then capacity as well as transaction capacity, which are 100 by default. So what this means is, so capacity is the size of the memory buffer up to which data can be streamed. In this case, the capacity is 100. By the time these 100 messages are generated, okay, into the channel, at least the first message has to be read by sync. If not, the source will not be able to write it into the memory. It will start running into out of memory issues. So the capacity determines what is the overall capacity of the channel to hold n number of messages at a time. Okay, if it is 1,000, it can hold up to 1,000 messages. If it is 10,000, it can hold up to 10,000. And the more number of messages you configure, the memory requirements will be high. Okay, and if your sync cannot read the data from that memory channel before the source fill the complete capacity of the memory, you will start running into out of memory issues. And transaction capacity is the maximum number of messages the source can write at any point in time to memory. Okay, so at max it will queue up to 100 messages and it will try to write into memory. Typically, this will be like 10% or 1% of your total capacity. Okay, so now as per the example given, we are using 1,000 as capacity and 100 as transaction capacity. It doesn't mean that until 100 messages are generated, it will wait. That is not the meaning of it. The meaning of it is how many messages it can capture in memory before the sync actually start reading the data. That is the purpose of capacity. And transaction capacity is number of messages can be buffered in channel by source at any point in time. Okay, maximum number of messages. Okay, now after defining source, sync, and channel, we have to integrate the two, integrate the three. So the source and sync is two discrete components which can be connected through channel. Hence, if you see a1.sources.r1.channels is given as C1, which means the source will be writing to channel C1, and sync will be reading from the channel C1 and writing to whatever target depending upon the type of the sync, which is logger in this case. Once you do this, once you save this, let me kill the other Flume agent. You can have it, there is no issue with that, but I just killed it because we are not doing any processing on the data. Okay, now I came back to this Flume example.conf, and now if I have to start, I have to say flume-ng agent. Name is, can you guys remind me the name of the agent? What is the name of the agent here? Flume-ng. Any guesses about the name of the agent? Name of the agent is A1. And conf, we have to give the path. It's always better to use fully qualified path. So it is this one. And then file. File name is example.conf. So this is the configuration file name. Okay, and hit enter. Okay, file is not correct. So to get the help, you can say flume-ng and hit enter. You will get all the parameters. You have to use -- file name, not file. Okay, so here I am going back and saying file name and hit enter. Okay, how come? So flume-ng. Okay, this is with respect to arrow. This is not the correct one. Okay, conf-file, not file or file name, but conf-file or -f. So this file name is about Avro client. So ignore that for now. You have to primarily focus on this one. Conf is for passing the directory name, and then conf file is to give the file name, and -- name is actually to name the agent. And if you look at the parameters, only these two are required. So either you can give it like this, or you can just say -- conf and give the fully qualified path. So, but in this case, I am giving directory separately and file name separately. Now it is started. Okay. So now you see, first let us confirm that our sync channel and source are started. So you see added syncs K1 for our agent A1, and then created channel C1. No issues here, no errors. And starting channel C1, does it say starting agent A1 anywhere? No, it didn't say starting agent A1 anywhere. Sorry, starting sync, yeah, starting sync K1. Yeah, you can see starting sync K1 here, starting channel C1 here, and starting source R1. So source is nothing but and then web service which is running on this port. So now as the web service is running on this port, I am opening another session and then run telnet or nc. You can use one of them. Localhost is the host name given. Okay, and port number is 44444 and hit enter. Now you see you got this terminal. So now we can actually send messages to the web service. We can say hello world, how are you doing? We have just started our first Flume agent. Let us see whether this data is logged or not. So to check whether the data is logged or not, you have to go to the agent, and logger will actually write the data back to the Flume agent itself, and you can see the data here. Okay, so this is how we can get started with Flume. Here the takeaways are the importance of the agent name, then configuring sources, sources, channels, and syncs, and then understanding different types of sources, channels, and sinks, and then we use netcat as source, memory as channel, and logger as sink. Now we will try to make it more interesting. Instead of using source as netcat, we will modify the same thing to read data uh, from our logs. So we need to identify which source should be used, and then we'll first stream it to logger itself. Once it is validated, then we will actually stream it into both logger and HDFS. So we'll try to improvise the same thing with different examples, and slowly we will explore all the at least two sources, two channels, and two sinks, or three sinks, including Kafka. Okay. So now let me kill this. The agent is killed. Once the agent is killed, your telnet also comes out automatically. I'm going to example.conf, and I want, instead of using netcat, I want to read the data from the log file. So first we need to explore different sources that are available. Okay. And exec is the source which can be used to run some Unix command and continuously produce data, to capture the data that is continuously produced data by the Unix command. It can be netstat, or it can be CPU stat, or it can be tail-s on the file where the data is being generated in consistent fashion, in continuous fashion. So the important parameters here are the type, which has to be exec, and the command. Okay, these are the two main things. So first we need to identify on which file we want to run the tail-s. So again, I'm going to opt gen underscore logs and ls-ltr. So this is the file on which we are actually getting the data, or on which the start underscore logs is pushing data to in continuous fashion. So we will use this location on the file optgenlogs slash access.log. Okay, now I'm going back to my home directory and then Flume example, and then start example, open example.conf. So here the source type, I want to change it to exec. You can explore others also, and you can integrate with other sources also, as long as they provide, or you can even develop. So Flume is actually developed in Java. You just need to understand APIs, and you can actually start developing your own source. So other sources that are available are thrift source, Avro source, JMS source, spooling, tail directory source, Kafka source, and many other things. Sequence generator source, another source which can be used to just generate events such as y, or some other thing, and then get the data from there. And syslog sources. So if you want to read data from syslog traits, you can do that as well. You just have to understand the syntax. What is the type is syslog TCP, and then you have to give the host name and port number. So even remotely, you can actually read the data from the logs that are being generated on the remote server. Okay, so you need to explore these sources and start using it as per your requirement. So exec is the type, and then to pass the command, first we need to understand the parameter name. It is command. So what we have to do, we have to say a1.source.r1. R1 is our source name, and instead of bind, we have to use command. And here you have to say tail-s opt gen underscore logs dot access dot log. Okay, Apart from that, I don't want to change anything. And let's see whether the data will be logged into the agent logger. And before starting it, it's better to run this command and make sure that this is valid command. Okay. Yes, it is valid. So I'm killing this. And now I'm starting again. I'm again typing the command so that you get it to your mind. So flume-ng agent, you can give the name. The name is A1. And then const slash home. And then conf-file. I just have to give the file name. The file name is example.conf and hit enter. Now the source is being started. Now you can see it's actually byte stream data. Hence you are seeing the values like this. Okay. Because we are not trying to convert into regular alphanumeric characters anywhere. Hence we are actually getting like this. No, actually, this is just header up to here, and then message started here, and it got trimmed. We are actually getting alphanumeric data only, but as part of the body, there is some information which it is trying to print here. I don't know what is the relevance of it, and then it is actually printing the data, and the data is trimmed here. Okay, it is the behavior of the logger. Now let us modify this and try to write this to HDFS. Okay, so when we say write to HDFS, what should we consider? Channel or sync? Any guesses here? Which one needs to be modified? Sync. So Ravati said sync. So we'll leave the logger as is, and then we will create one more sync. So here I am saying H1 to say it as HDFS. Okay. Let us see whether I will be able to do this. Let us see the existing architectures which are demonstrated here. So one says you have to have multiple channels connected to sync so that one sync is written to HDFS and another sync is written to JMS and another sync is written to source. So we might have to create two channels, one for each sync. Okay, so here let us start naming little bit different. Okay, I'm replacing R1 with the log source. Okay, so that is the source, and then channel P1 to logger because we want to write to logger. Okay, and also sync A1 also to logger. Okay, and now I want to create a new sync which is HDFS and also channel HDFS. Okay, so first I am saying describe the sync. Okay, our agent name is still A1. So A1.syncs dot HDFS dot type. So now if I have to use HDFS, if we go here, HDFS sync, if if you look at the properties, the most important properties are type and HDFS path. Okay, so type is HDFS, and then a1 dot syncs dot HDFS dot path. We have to give HDFS colon slash slash nm01 dot itversity.com. 8020 is the port number, and then user D Gadi Raju Flume example in the directory. Okay, and then we have to configure channel. Use a channel which buffers events in memory for HDFS. Okay, so here I am saying a1 dot channels dot HDFS dot type equal to memory, and then I will copy these two lines. HDFS. Okay, we are using the same settings because if it is Kafka queue, it's a different story. But when it comes to memory channel, each sync has to connect to one different channel. You cannot actually channel to multiple syncs in all the cases for all the channels. For memory and file, you might not be able to do that. You might have to use some special channel so that you can actually stream data to multiple syncs using one channel. I'm not sure whether it is possible or not, but in general, we need to have a separate channel for each sync. Now we have to integrate our source, which is A1, with sync HDFS through channel HDFS. Okay, so now what I have to do, A1 dot sources dot log source dot channels equal to HDFS, and also A1 dot syncs dot HDFS dot channel equal to HDFS. Okay, so what we have done, we have one source, so it will depict this one. It will depict this one. We have one source which is logger, log source, one channel and sync which is logger, which will log into the logger, and another channel and sync which will write into HDFS. Okay, and if you go to HDFS sync, there are other important parameters which we will see later. First, let us see whether this most basic one will work or not. Then we will try to improvise rather than first trying to include everything, and then if it fails, instead of struggling, let's start with the most basic parameters, which is type and HDFS path. Okay, and here let us give slash at the end as shown in the example. Okay, now save it, and then let us run the agent. So there is some issue. Agent configuration for A1 does not contain any valid channels, marking it as invalid. Okay, so let me see how we can give multiple channels. Okay, it is space. Let us try that. Okay, now it looks good. Okay, there seems to be some issue. HDFS path is required. So I did not give the HDFS path. So that is why it is very important to scroll up and make sure all the sources and agents are running. Sorry, sources and sinks are running. So it is complaining about HDFS path. Okay, our sink name is also HDFS. And then we have to give HDFS dot path. So that is why it is failing. So if you go to the syntax, type is just type, but our sink name is HDFS. So HDFS dot type is fine. But when it comes to path, it has to be HDFS dot path. So let me do one thing. Okay, let me change HDFS to HDFS sync to avoid the confusion. Okay, and then HDFS dot path. Okay, so now let me save it. Okay, and now let me vi example.conf, right? Yeah, I don't know how to remove this. Let me search for. Okay, that is fine. Now let me start the agent. So first thing you need to make sure is everything is started. Again, there is some issue. Channel HDFS not in active set. Okay, so I'm closing this and opening it again. I know what the issue is. Channel is HDFS. Okay, here I have to name it. So the issue is when I replace HDFS with HDFS sync, the channel name also replaced with HDFS sync. So let me change it to HDFS channel. And here also let me name it to HDFS channel, and here also channel. So very important to interpret those errors and try to resolve those things. Okay. Always make sure the agent is started without any issues. Don't just relax by seeing that the final message is successful. Still there is some exception here. Okay, now again it is comparing with respect to channel only. BI example. Okay. A1.channels HDFS channel. Let me search for HDFS sync. Okay, I'm not sure where it is complaining. Let me start it again. Okay, what it is complaining on? No channels configured to log source. Okay, I know what the issue is. Now come out of this vi example.conf. So we have another source called log source, and log source dot type is exec. Log source dot command is this one, and then we have to integrate log source channel to logger and logger.channel to logger. Okay. Okay, I know the problem. So here, let me name it as logger sync. I think because the channel name and sync name is same, it might be creating some issue. So logger channel. Okay. So this is sync. This is also sync. This is also sync. This is also sync. So be careful with the typos. Okay. And then logger channel. Logger channel. Sorry, this is logger sync. And now let us try. So no configuration found for this invalid agent configuration. Invalid for agent A1. It will be removed. Does not contain any valid channels. Again, there is some issue. So logger channel and SDFS channel. Okay, I know the problem. Here it should be channel. Sync we have only one parameter. It is type for this logger. Okay. The channel we have three parameters and logger sync dot channel. I think this should work. I will revisit all the parameters once again if I get it correct. Okay, now again there is some issue. Could not configure sync SDFS sync due to the channel SDFS channel is not in active set. Could not configure source log source due to no channels configured for log source. Okay. Here I have to say HDFS channel. I think again it might be issue. If it did not work, if it do not work this time, then I will try to come up with some other solution. So now it is only about HDFS sync due to channel HDFS channel is not in active set. So logger is working. Now you see I am getting data in logger, but HDFS is not working. So let us troubleshoot that issue. That's good that we are almost there. So sync channel is HDFS channel and yeah, I know here it has to be HDFS channel, not sync. Now it will work. Now let me start it. Now you see there are no exceptions here. Data is being logged here. And also I'm trying to run Hadoop fs-ls user d Gadiraju. And there should be a directory called Flume example here. See, here is the Flume example directory, which is just created. Hadoop fs-ls and hit enter. And you can see data is being written to here. But by default, it will be sequence data. So you will not be able to read the data. Sorry, cat. Okay, it has written in, I think it's still written in sequence file format. That's why you see some special characters. If you want to write it in text format, we have to explore other parameters. So now let us see how to explore the other parameters. But before doing that, let us understand what we have done once again. Okay. So here, if you look at example.conf, let's go to the first line. Let me. Okay. Now, if you see, I have only one source, which is log source, and then sync, which is logger sync as well as HDFS sync, and logger channel for logger sync and HDFS channel for HDFS sync. So the source, as we have only one, the source type is exec, and we are trying to read the data from access.log. And the sync, there are two syncs. First, we are trying to configure for logger sync. Okay. And for logger sync, we want to write the data to logger. And then we want to define properties for logger channel. Okay. So we have memory channel and we have capacity and transaction capacity properties for that. And then when it comes to writing data out of one source, we have multiple channels. That's why you see the parameter is named as channels, not channel. Earlier, I separated these two things. That's why we ran into issues several times, and it took time for me to troubleshoot. As it suggests channels, we can write data from one source to multiple channels. Okay, that is why if you go to the architecture diagram, in all the pictures, we have only one source. Okay, this one have one source, this one have one source, and this one have the main one also one source, one channel, and one sync. Even for the consolidation, we have one source, but we are trying to read from multiple web servers. Even with multiplexing flow, we have only one source. Okay, but we are trying to write to multiple channels. So for that reason, we have to specify all the channels to which we want to write data from this source. So in this case, we have two channels, logger channel and HDFS channel. And then we are integrating the logger sync with logger channel. Now we created the second sync, which is HDFS, and path is this one. And then we have given type as memory channel. We have configured channel after configuring a sync, and channel is memory type. And finally, we are integrating the source with HDFS sync through HDFS channel. So this is the integration point between the log source and HDFS sync. Is everything clear here? Now let us improvise a little bit and try to write data into HDFS in plain text format. Okay. For that, and this is very important parameter, if you go to the syncs here and go to HDFS sync, if you scroll down for the properties, one of the property so let me explain this one, a few of the important things here. the first one is file prefix. So if you want to prefix your files with something, you can use file prefix, you can use file suffix. And also when you specify file prefix and file suffix, if you want to timestamp, you can use these things. Okay, so we will see that later, how to, probably tomorrow, how to timestamp the directory names or the file names using prefix and suffix. And then other one is roll interval, roll size, and roll count. These three parameters will actually determine how frequently the data has to be written to HDFS. And then batch size, and then file type. File type is either sequence file or data stream or compressed stream. So if you say data stream, it will be written to text file format. By default, it is sequence file. That's why we see special characters within the data. The data is written in the sequence file format. Now let me define this HDFS file type. Sync.hdfs sync.hdfs.file type, and we have to give it as data stream, and save it. Okay, and let us delete all the entire directory, rm-r user d Gadiraju Flume _example. I have deleted the entire directory, and now I am running it again using flume-ng agent command. Now, due to the logger, you will be seeing the data stream here, and also data is being written to HDFS. So we can open another directory and another connection and run Hadoop ss-ls on that Flume example directory, and data is being generated. Copy this one. So if you see, the file suffix have the timestamp, which is Unix timestamp. If you change it into more readable timestamp, we can do that, and we will see that tomorrow. Hadoop ss-cat and paste it here. Now you can see each record is separated by a different line, and it is not sequence file format. That's why you don't see special characters. Okay. So that being said, as of now, we have seen how to get data from Netcat and stream it through logger and see the results. And also we have seen how to read the data from the log file and stream it through to logger. And then we have seen how to read the data from log file and stream it to both logger as well as HDFS, which is similar to multiplexing flow as part of the architecture diagram. So we'll try to improvise these things. We have to understand few more important parameters, especially with respect to HDFS. And also when it comes to channel, we have used 2 memory channels. Instead, we will try to use file channel tomorrow and try to see what are the important parameters with respect to file channel. And we'll try to stream it to both logger as well as HDFS. And then we will get into Kafka tomorrow. Okay, so that being said, if you have any questions, let me know. Otherwise, we will wrap up for today. Any questions? Is it going fine, or do I have to slow down a little bit? Let me know if you want me to adjust a little bit towards my pace or my content, whatever it is. Okay, I will highly recommend to practice a lot because you can make silly mistakes to begin with. Unless you practice and you understand the dependencies between source, channel, sink, the terminology of IP addresses and port numbers, you will struggle a little bit. And also when it comes to CCS certification, Flume is part of the curriculum, but as of now, I haven't heard anyone got any questions from Flume. But in future, after the changes to syllabus, probably they might ask 1 or at max 2 questions on Flume, Kafka, as well as Spark streaming. I'll be surprised if they ask 2 questions also. Mostly it might be 1 question. Okay, that being said, it seems there are no questions. Thank you very much for joining the session, and we'll catch up tomorrow. We'll continue on Flume, and we'll transition ourselves to Kafka, and probably by day after tomorrow, we'll get on to Spark streaming. That being said, I'm stopping sharing and disconnecting. And those who are on YouTube live session, thank you very much for joining the session. We will catch up tomorrow. If you like this video, please click on the like button. It's here. If you want to share with your friends, please click on share and share with your friends. You can share on any social networking platforms. Once again, if you want to practice with all the content which I'm showing here, you can sign up to my lab at labs.itversity.com. The plans are $14.95 for 31 days, $34.95 for 93 days, and $54.95 for 185 days. Even if you are not subscribed to my lab, or even if you are not part of my live training, still you can go to discuss.itversity.com and start posting these questions if you run into any issues. And there are people who are actually answering those questions. That being said, thank you very much. Bye.